Hi, this is JPA from LeanWisdom. Welcome back to the Weekend Stories video series. This story is about quality, right? How did we improve quality in Intel security way back in 2012, 2013 times? Yeah. So in Intel security, we formed a core committee, core group of people who were responsible for defining quality across the products, right? I was representing India Center, and I was responsible for coming up with some thoughts and some ideas on how do we improve quality. So what I did was, I instead of sitting inside a four walls and defining a quality for the large enterprise, I thought let me first look at how is the quality in the current organization, right? So we looked at 100 plus products. This company is big and there are quite a few products. We looked at 100 plus products. We did a quick study of all these 100 products, right? I was part of this study, doing a study of how is quality, right? Is this product known for good or bad quality? First thing. There were escalations from customer because of quality. There were escalations from leadership to the teams, and the last minute too many defects, right? Post release defects from customer. All these were identified as not so good quality, right? Bad quality. But there were also teams, products where they were able to build quality into the system from the beginning. So we want to understand how are these practices in the organization, right? So out of 100 plus products, the surprising thing that we saw was 12 out of 100 products, 12, 1, 2, right? 12 out of 100 products stood out kind of unique in terms of quality across all the products, right? That was like good step, first step for us. Then what we did, I double clicked on these 12 products and going a little more deeper on these 12 products, understanding what is that they are doing that these products are of good quality, right? So how did we define first? First we looked at the lagging metric. Lagging metric is like number of customer defects, right? Number of defects found by customer post release, number of defects that were found around the release time, where the leaders had to get into a go no go call and then looking at the defects and reviewing it and so on. So there are certain metrics we defined to define, first of all, understand whether the product is of good quality or bad quality, and post release 3 to 6 months, right? What is the customer feedback and so on. And in the study we also try to look at kind of leading metrics. How did they ensure quality? Was there any metric that they defined in finding this, right? So what we found was, I found certain things which are very common across these 12 products. First of all, these 12 products are not from one department or one business unit. They were spread across all the departments, all the business units, across the locations, right? India, US, Europe, Canada, right? China, all these locations. So across business units. So it is not that they were talking to each other and doing it. They were just practicing certain really good practices in terms of quality, right? So the rest of the video is going to be about what did I see which are common across 12, as well as some practices which we saw in some of those teams which were standing very unique, right? Standing very, very amazing, that brought a great quality. Okay, let me explain one by one. The first thing that we saw was pretty much all of them had a leading metric in terms of quality. What does it mean? Hey, how many defects we have found through reviews, right? I'll give you one other insight from the industry. There was a report published by Standish group, right? It was one of the very popular group that does a lot of study. They have done a study out of 1,000 large projects, and these projects were waterfall projects, and they found that out of these 1,000 large projects, 65% of the defects found very late. Please listen to me. 65% of the defects that were found very late, post release to customer or around the release, were actually injected in requirements. In requirements. Yeah. So what does it mean? Requirements defects that kind of moved all the way from here to the release, and end of the release or post release we found the issues, right? So you can imagine how bad is our quality in terms of requirement that impacting your actual customer release, right? So this was a great study. These 12 teams were actually doing a reverse. They were actually started finding a defect on the leftmost of the value stream, right? Hey, how many defects we are finding in requirements that were injected in requirements, right? A defect that was injected in requirements should have been found in requirements. So they went very strong behind writing a good feature with acceptance criteria, very good definition for an epic, very good definition for a story, and every story should have a clear acceptance criteria. Story should be small enough that it can be done in a sprint, and the story is accepted only when the acceptance criteria is met, very closely reviewed by a product owner, end of every sprint that was demonstrated, and so on, right? 12 products. So first step, requirements have to be taken care, right? It was a great learning. It is not that out of these 100 products, only these 12 were agile. There are many other products which out of these 12 were, they also claimed that they are agile, but they still had a lot of problems, right? So the way you implement this thinking, right, agile as a mindset, right, being implemented in the organization, in the product line matters. So these teams, 12 teams, were looking at clearly a defect, right, found in every state. Right, number one. Number two, they were focusing a lot more on reviews, right? They defined, later we defined this as early defect detection. They didn't have a name for it. We came up with a technique called, or a word called, early defects. So we kind of segregated the defects into two parts, because these 12 teams were focusing a lot more on the left side, early defects, and there were defects that were found through late defects. Let me define what is early defects and what is late defects. Early defects are found through non-testing practices. For example, review practices, requirements review, architectural review, design review, code review, test review, right? All these are reviews. Unit test automation, static analysis. Anything that was found before the testing practices were called as early defect detection. We defined it as early defects. Right? These teams were focusing on finding more defects through early defect detection. It doesn't matter whether you are finding it today, you are finding after 3 months. The defect found through these practices, we call it as early defects. So what are the late defects? Any defect that you found through, through testing practices like functional testing, integration testing, system testing, regression testing, end-to-end testing, right? Or UAT with the customer and customer finding defects through their testing. All of these were found through kind of black box, which was not found by reviewing things, it was just by testing, right? So quality is confirmed through testing and the defects were found, we called it as late defects. Now early defects and late defects, these 12 teams were focusing on early defects, right, and finding early defects. So what they focused was on, they used to create a tough teams or tough backlog items, or very critical backlog items which had to be thoroughly reviewed. They created something called peer review process. Let me talk about what is peer review. Peer review is like a review done by a group of people, not by one person. If I write a code, for example, let's take an example of a code. If I write a code, the code is not just given to one more developer who is also busy with some other work. Right? It's not just given to one person, it is given to a team of peers. The team can be my own, another developer who is sitting next to me in my team. It can be an expert, technical expert, maybe like a technical lead or architect. It can be a domain expert who can also be like a product owner. It can also be, there can also be a tester, right? A pure manual tester who is also sitting and reviewing the code. Now what does it mean? I have written a very critical algorithm, right, and I am projecting it in my screen, and these 4 people are looking at this and reviewing simultaneously at the same time together. Objective of peer review that was defined was to find defects. Every review primary objective was not just a review but finding defects. Okay, so they found every review, they were measuring how many defects were found in this review, right? And they started finding defects because the objective was very clear, right? And the peer review, the next thing that they did was, in 1 hour of peer review by 4 people, they maximum reviewed 100 lines of code, right? Focused on high quality review, not just rushing through the code and say, yeah, it looks good, right? 100 lines of review for 1 hour of review, right? And the defects that were found were immediately logged. There was a separate tool, right? Later we defined a tool. These 12 teams were recording in different ways. Somebody maintained Excel sheets, somebody had a small tool that they developed, somebody was using even defect management tools, right? Defect life cycle tools, all that, but in different criteria and so on. So later we defined a common tool for logging peer review defects. So they were tracking defects to closure. Defects have to be closed for the testing to start, right? Very separately they were tracking defects, right? So they were very serious about this, right? So peer review. They also focused on increasing unit test automation, right? Finding good number of defects through unit test, the code coverage of unit test, right? Condition coverage through unit test, or statement coverage through unit test, right? All these they defined with a goal that minimum 80% of the code should be covered. Very good analysis, static analysis tools were injected into the system, and they were also finding defects, right? So all these things together, a good peer review for requirements, for architecture, for design and for code, as well as doing a unit test automation, focusing on static analysis and so on, were helping them to find a lot of defects, right? This is another great thing, right? On the other side, one of the departments out of the remaining products, it was really bad in terms of quality. When I looked at that, I found that I pulled almost all the reviews I did in the last 2-3 years, and I found 4,000 reviews with 0 comments, with 0 feedback. Can you imagine? On the other side, this is one of the products, right? And so it was done for the sake of doing, wherein these 12 products, they were very focused on finding defects, right? And they were open with that. It's okay to find defects. Finding defect early was celebrated. It was not considered as a bad thing. It was considered as a good thing that we found, right? So that also happened. They started tracking. So what we did is, later, by looking at these practices and so on, we started pulling this into into the entire system, right? We started conducting peer review classes. What is peer review class? We conducted a training session on what is peer review, how to do a peer review, and we used to challenge the teams that, hey guys, come with a production code. We will conduct 4 hours of training on peer reviews, right? And those 4 hours of training on peer reviews will help you find defects, right? We will ensure that you will find at least one defect of your production code in these 4 hours. And people were like challenged. Oh, is it possible? They came for a peer review. Most of the teams found at least one defect. There are teams who found half a dozen defects in their production code, and some teams found at least one defect. Very, very few teams could not find, but otherwise majority. In 100 lines of code, we did this exactly, that 1 hour of review, maximum 100 lines of code, and that 100 lines of code, at least they should find one defect. And they were able to find, because we have taught them this, right? Now, bringing a cross-functional team, including a tester, was a challenge. Why? A senior developer kind of felt that it's an insult for me if a manual tester is sitting and reviewing my code. This is a challenge that I got, right? People are like against this. Then I had to tell them, guys, what is wrong if somebody is giving you a defect, right? Why are you resisting this? Don't resist. Let this happen. Let's see what happens, right? So, and on the other side, the manual testers were also not very confident that, hey, will I be able to even look at the code and find? I had to tell them that, hey, don't worry. It is happening in some teams. Why can't you do it? Right? You need to know your power. Like, you are a tester. You are able to find a defect without even seeing a code. Why can't you find a defect by seeing a code? Right? You are finding all the defects without seeing a code, right? Now you are seeing a code. And why can't you find? Yes, possible. So we prepared. We started giving them cross-skilling, right? We brought this program called SDET, right? Software Development Engineering Test, where we will give you some basic knowledge on the tool, like for example, C++ or Java, or some basic knowledge, we'll training, right? So that you are equipped with some basic knowledge. If you want, you can take it forward. They were good. After 6 months, when I injected all of these, after 6 months, when I looked at the number of defects found, The maximum number of defect was found by one of the highly technical and a technical lead who had a solid domain knowledge, right? In that group of 500 people, approximately 500 people, right? The second highest defect in peer review was found by a manual tester. Can you imagine, right? When the leaders were skeptical about it, when the developers were skeptical about getting this code reviewed by a manual tester, the second highest defect was found by one of the testers. Let me add one more story to it, right? So this one developer that I was talking, one tester that I was talking about, who found the second highest number of defects, this guy, I met him in Bangalore airport, maybe 6 months or 9 months back, right? I saw him, he saw me, after 10 years I'm meeting him, yeah? So he came running, JP, how are you? Nice to meet you. I said, yeah, all good. So how are you? He said, yeah, good. And and I asked him, where are you? He said, I'm still in Intel security. I'm being part of the same company, right? Oh, great, right? What are you doing today? He said, I'm a senior architect. A manual tester 12 years back, right, who was identified for testing, just because we made him sit in a code review, because we helped him in learning the foundation, some basic language, his interest was, he was passionate about learning. He went ahead, nobody could stop him. He went ahead and learned so many things. He's a senior architect today in the product. Can you imagine, right? So who defines that this person should be only a tester? Nobody. None of us are eligible to even define whether this person should be a tester, right? He became a senior architect, right? This is another interesting story. So, and then we brought unit testing tools, we started measuring all of this, and then we saw team by team improving quality, right? Because, so another interesting data that I also found was when we implemented this over a period, right, we saw huge impact from early defects. It's one of the large groups, right? We went very, very stringent on this group because the leader was super excited about this in implementing. We have kept almost 8 to 10% of our capacity, the team's capacity on reviews. Approximately 10% capacity, 8 to 10%, right? When they kept 2% of the capacity, 2 to 3%, they found around 8% or 10% of the defects through reviews. When they kept 8 to 10%, the percentage of defects found through early defect detection techniques were almost 80 to 90%. And the best team that I saw was finding around 92 to 93%. 93% of the defects found through early defects. But means what? Only 7% or 10% of the defects found through all the testing techniques. Functional, integration, system, regression, all of these together, they found only 10%. And pretty common was that 15% and 85% or 80%, 20%, pretty common, right? This particular initiative increased the quality of many products, right? Then we had sessions with the leaders, we had brown bag sessions with the testers, we had sessions with every team, formal injection of these in their planning, right, in their PI planning, in their sprint planning and so on, started measuring it. So that gave a big result. So another big learning for me was, measurements drive behavior of the organization. When I started measuring what number of defects or what percent of defects come through early defects and started focusing on that, it actually happened, right? We started measuring, the culture of the organization changed towards that, right? Good number of teams. So I hope this video was helpful for you. If you think you can practice some of this, and if you need any tips on this a little more deeper, feel free to reach out to me. Hope it was a good video for you. Have a good weekend. We'll meet you next week. Thank you.